So you did these 4 examples already with your quadratic formula. The first time we got what I'm going to call 2 nice answers or 2 rational answers. No square roots, nice numbers. This means you could have factored this question. This first one, the 5x squared minus could have been 5x and x, and then working with the outside and the inside, I could go 2 and 4. My outside is 10. My inside is 4. Does 10 and 4 ever make negative 6? Yes, if this would be negative 10 plus 4. And then if you solve this, x would be 2. And x would be negative 4/5. And that's exactly the same as what we got with our quadratic formula. So sometimes it can be factored. There's something in the quadratic formula that tells us that. Second, so I'm going to just put a note beside this one. We call this one 2 rational roots. Roots is another word for solutions or answers. This one has 2 nice answers. The second one that we did with our quadratic formula also had 2 answers. But it included a square root that could not be simplified. That one had 2 irrational roots. Number 3 had 1 nice answer, 1 rational root. And the last one had no solutions or no roots. Technically, the textbook here uses the word no real roots, because if we used imaginary numbers, we could make something happen. But we don't deal with imaginary numbers. We just deal with real numbers in this course. And so this one has no answers. Now there's something in each of these 4 that tells us whether or not we're going to have 2 nice answers, 2 irrational answers, only 1 answer, or no answers. And the key to that is actually just what's inside the square root. Can you see that if what's inside the square root is a nice number that you can square root, like 25 or 49 or 64, you will always get 2 nice answers because that square root is perfect. If what's inside the square root, right, so this first one, what was inside the square root was something perfect, then you got 2 rational roots. In the second one, what was inside the square root was something you couldn't square root, and so you got 2 irrational roots. And it makes sense that you get 2 because you have plus or minus something. The only way you would get 1 is if what you are plussing and minusing is 0. Does that make sense? So if the b squared minus 4ac is 0, then you'll only get 1 root. And if the b squared minus 4ac is negative, then there will be no answers, because that's impossible. So what we're going to do is on page 229, we are going to highlight these 4 different things. Go back. Here we go. Yeah, okay. Okay. And at the top of, next slide, at the top of page 229, I want you to write this word down. Right at the top of page 229, I want you to write discriminant, because that's what we call that part of the quadratic formula. the b squared minus 4ac is called the discriminant. And what it does is it tells us how many answers we're going to have. So this example is at the top of page 229. Beside it, we're going to write, this is the first example. The b squared minus 4ac is a perfect square. The discriminant is a perfect square. The result is two rational roots. Two nice answers. And it means it could have been factored. Maybe I'll put factorable in brackets. So we look at what happens here, that discriminant part is 16 here, a perfect square. What's inside the square root is a perfect square, which means you could make it 4 and then you get two nice answers, which means your original question could have been solved by factoring a lot quicker than the quadratic formula. It also now gives us a way, if you want, you can use that. When you have a question, you can say, well, let me just look at b squared minus 4ac to check if I can factor it. Instead of wasting my time trying to factor it, I want to know, can I factor this? What is b squared, which would be 4, minus 4 times 1 times a negative 3? That's 16. Yes, I can factor it because it's a perfect square. So that's type 1. Next one. Beside this one, I want you to write the number 2, and the b squared minus 4ac is greater than 0. I'll write it in words. I'll write positive, but not a perfect square. What do I mean by that? We figure out the value, we get the square root of 8. 8 is not a perfect square. What does this mean? We still have 2, but this time irrational roots. So if it's positive but not a perfect square, it has 2 irrational roots, and you cannot solve this by factoring. You would either have to use the square rooting method or the quadratic formula. Number 3. Besides this example, the b squared minus 4ac equals 0. And if you plug it into the formula and it's equal to 0, well, that means you're plussing 0 and minusing 0. There's only one root. It also means that it was factorable. We could have solved this with factoring. And finally, on page 230, the fourth one, the b squared minus 4ac is negative. Wow. You can't square root a negative number, and there will be no real roots. So our discriminant tells us how many answers there's going to be. It tells us whether it's factorable or not. It's really helpful that way. Sometimes people figure out just the b squared minus 4ac instead of doing the whole formula to see where they should go next. Should I just stay with the formula? I'm like, it's really, like, here's your formula, right? Whether you do just the discriminant part or the whole thing is not really that much more, right? Because the other ones you just are plugging in the numbers. Sometimes it's nice to write out the whole thing because you can see, oh yeah, that's why there's 2, because I'm adding or subtracting a positive number.
On quizzes and tests, if we do find out that the b squared minus 4ac is negative, should we just say that there's no root?
Yeah, as soon as you find out, and you'd be like, no solutions, and you wouldn't have to show any more work. Right? Like a whole test. Well, would that, psychologically, how would that go for you? Whole test where everything's no solution.
That would maybe be true, yes. So few solutions in
Yeah, but it'd be too obvious, and then you start second, would he do that? Or would he put 1 on there that wasn't? Right. I make them all the questions 1 mark, except the middle one I make 8 marks. And they're still all no solution. But wouldn't you second guess yourself on the 8-mark one? I can do all these psychological experiments for free. This is so nice. Okay, let's go to example number 1. Without solving, this is okay. This is their hint to say, use the discriminant. I would prefer, actually, if the questions, instead of saying without solving, said, use the discriminant to determine whether the equation is blah, blah, blah. Because if someone solves this, do I have to take off marks? You've done too much work. Okay? So we're going to figure out what the b squared minus 4ac is equal to. In this case, my b is -6, that gets squared, minus 4. My a is 9, and my c is 1. -6 times -6 is positive 36. Minus 36, this is equal to 0. What does that mean? Does it have 1, 2, or no roots?
1.
It has 1 root. We don't need, like, we could find it. Okay. It also means, like, if I did want to solve this by factoring, I could. And if I wanted to solve it by factoring, since there's only 1, both of these have to be identical. So should I use 9 and 1 or 3 and 3? If they both have to be identical, I should use 3 and 3, 1 and 1. Oops, almost. To get a -6, does it make sense they both have to be minus? Multiply it out, it works. And so the only solution, right, both of these are the same, there's only one solution. Do you know what some textbooks call that? This is terribly confusing. They say, how many answers do you get? And they say, 2 equal roots. How many answers are there? There's 2 answers, but they're the same. Wasn't that one answer? But you'll see some textbooks call that 2 equal roots. Because it happens twice. Which is kind of important in other things, but really it's only one answer. But we didn't need to solve this, so I guess I have to deduct myself 1 mark. Because I went too far? I don't know. So this, without solving, they want you to just use the discriminant. All right, circle questions 4, 5, 7, and 12. And we're going to do question 2 right away.